An independent samples t-test is also used to compare two means of two independently sampled populations. The first set of hypotheses in an independent samples t-test is testing the variance. It has to be assumed that within each population, the variable of interest is normally distributed with equal variances to move on and determine if the means are equal. Afterwards, we can proceed to evaluate whether there are significant differences in the means of the two independently sampled populations. To get a better idea, let's check out the following scenario. In this example, 20 Petri dishes each contain 10 celery seeds. 10 of the dishes were kept in the dark for 1 week. The other 10 were placed under a grow light for the same amount of time. At the end of the week, the number of seeds that sprouted was counted in each dish. With the data collected, we want to answer the research question: is there a difference in the average number of seedlings grown in the light and those grown in the dark? The first null hypothesis regarding variance states that the variance of the seeds grown in the light is equal to the variance of the seeds grown in the dark. Once equal variances are assumed, we can proceed to the second null hypothesis, which states that there is no difference between seedlings under the light and in the dark. Before we begin, let's download and open data file seedlings.sav so that you can follow along. After locating and opening data file seedlings.sav, go to the Analyze menu. Point to Compare Means, and then select Independent Samples t-test. After the Independent Samples t-test dialog box appears, find the seedlings variable in the list box on the left, then select it by clicking on it. Then move the seedlings variable to the Test Variables list box by clicking on the top transfer arrow button. Then go back to the list box on the left and select the treatment variable. Transfer this variable to the Grouping Variables list box by clicking on the bottom transfer arrow button. Whenever you see question marks next to a variable, it means that it needs further input. Click on the Define Groups button, and the Define Groups dialog box will open up. Click in the Group 1 text box and type in 0. Then, click in the Group 2 text box. Then type 1. We have just defined the dark group and the light group. Click on the Continue button after you've finished. Click on the OK button in this dialog box, and the results of our independent samples t-test will appear in the Output Viewer window. Let's read the independent samples t-test output table. There are 2 rows of data. The second row is blank under the Levine's test for equality of variances, so we go to the first row in order to get our analysis. The first row states that equal variances are assumed. Also, the sig value is 0.184, which is greater than alpha. We fail to reject the null hypothesis, which states that the variances of the seeds grown in the light is equal to the variance of the seeds grown in the dark. Since equal variances are assumed, we can now proceed to compare the means. To see the rest of our results, let's scroll our table to the right. The mean difference in seedlings sprouted between the 2 treatments was negative 2.900. The value of t at negative 3.179 was statistically significant at a p-value of 0.005. This is less than alpha, which leads us to reject the null hypothesis that stated that there is no difference between seedlings under the light and seedlings in the dark. So to answer the research question, is there a difference in the average number of seedlings grown in the light and those grown in the dark? The answer is yes.